Hi and welcome to the video today, which is covering exam style questions for A-level and Scottish Higher Maths. In this question we're going to be looking at a function f and we need to find its inverse. So a function f is defined as f of x equals 5 plus a half of x. So we're applying the function f to x. Find the inverse function f minus 1 of x. A couple of useful things to know. F of f minus 1 of x is just x, and f minus 1 of f of x is x. So the order you apply it doesn't matter, and we're assuming that f is a continuous function, obviously. In this example, it is a continuous function. Normally you'll be given a continuous function in any kind of question like that. Okay, so don't worry about the continuity bit of it. Basically all this is saying is that for any function f, when you apply f to a number x, a variable x, then to get back to x, you need to apply the inverse function, f of minus 1 of x. So we have f of x, we want to get back to x, so we need to apply f of minus 1 of x. Okay, likewise, if we already know the inverse function, f minus 1 of x, then for any number x is a variable, so once we apply f minus 1 to x, then if we then apply the function f to that result, we get back to x as well. Okay, so we'll be using both of these arguments in any questions to do with functions like this. It's entirely up to you which one you want to use. Some situations it's easier to use one than the other. Most likely I'm probably just going to use this one because we are already given f in the question and we're asked to find f of minus 1. So if you're asked to find f of minus 1, whatever you're asked to find, it's better if you use the 1 if that's inside the bracket. So the internal function. So you're better to use this rule to find it rather than this one. So let's do that. Let's use this one to find f minus 1 of x. Okay, so like I said, this applies to any function. And as I say, don't worry about continuity. Okay, so this is our function here, f of x equals 5 plus a half of x. Find the inverse function f minus 1 of x. So what I'm going to do is I'm going to take f of f minus 1 of x. Okay, so basically we're replacing x with f minus 1 of x. So what's that equal to? Well, that's just 5 plus a half f minus 1 of x. Yeah, so you're plugging in f minus 1 of x into here, and then you have to plug it into here, obviously. Right, now we know what this is. This is equal to x. Okay, it's this one here. It's the first one. All right, so this is just f of its inverse, so it's just x. So x is equal to 5 plus a half of f minus 1 of x. Right, so we can tidy this up a little bit. So let's take the 5 across, so x minus 5 equals a half f minus 1 of x. Let's bring that to the other side and multiply by 2. So f minus 1 of x is equal to 2 times all times x minus 5. Okay, so you could leave it like that, or you can multiply it out. You could multiply it out and just say 2x minus 10. It's entirely up to you, or you can leave it as 2 upon x minus 5. So that's the answer, right? So I'm going to put a little box around that. So that's the answer. And what we can do is we can check that. So let's check that for a value. So let's plug in, I'll do it over here. So let's plug in f of 2. So that's equal to 5 plus a half of 2. I'll just rewrite the original function down again, just so you can see. Right? So what's that equal to? Well, that's equal to 5 plus 1, which is 6. So what we've done is, f has taken 2 and mapped it to 6. Right? So what f minus 1 will do, f minus 1 will do the opposite. So it will take 6 and map it back to 2. Now we need to go and check that it actually does that. So f minus 1 of x is equal to 2x minus 10. So f minus 1 of x is equal to 2x minus 10. So f minus 1 of 6 is equal to 2 on 6 minus 10. And that equals 12 minus 10, which equals 2. So yes, it does in fact do that. Okay, so it's good to check the answer. And that's essentially it. So, as I say, we just applied this first rule up here. Sometimes we will apply the second rule, depends. But because we're being asked to find f minus 1 of x, it's easier to use the first rule. And then it's always good practice to check your answer. So when you map, f maps a value to another value, so it maps your input to your output, a to b, and then f minus 1 maps b back to a. So it's just the reverse process. So you need to find the function that takes your value back to where you started from. And it has to work for every value, of course. Okay, so I'm going to be doing some follow-up videos, because some of these questions introduce reams of new mathematics and ideas and concepts which I don't really want to cover in the exam style questions themselves. The exam style questions, I'm just really trying to answer the question as if I was writing it on the exam. In an exam, you wouldn't have to go and explain all the concepts. You just do your working out, get the answer. But it's good to know where these things come from, and it's good to look at generalizations and the underlying concepts. So we will be looking at that in some follow-up videos connected to this. I'm going to be looking at functions in general, finding inverses of functions, and things like when is a function equal to its inverse, for example. Stuff like that. Okay guys, so lots of good exciting things to come. Stay tuned. So thanks for watching the video. Please share, like and subscribe, and I will see you on the next video.